after some time. Yeah. Okay. We are here for the revision and WAEC practical that you are going to write on Tuesday. And today we are going to focus on all about iterations. Then tomorrow we'll finish up with qualitative analysis. Let me share my screen, then I will tell you what we are meant to do for today. Am I here? Excuse me. It's TW WAEC revision. Iteration. Okay, good. All right. Get your pen and paper. Let's move. Just okay. Okay. We are going to start with the key points. The things you need to know in your titration analysis, then the errors you should avoid, and the penalties following different errors committed, so that when you know them, you know how to avoid them. I want to tell you something. Practical is about 25% of the whole exam. Theory is about 50. Then objective is about 25. Now, it is very possible and easy to get 25 over 25 in your practical. It is more difficult to get everything in theory than in practical. It is very easy to get the whole mark for your qualitative analysis. That's your paper 3. Very easy. So what we advise students is try as much as possible to gather at least 20 marks in your practical. If you can get up to 20 marks in your practical, there is nothing that will make you fail this exam. Nothing. And it is very, very easy to get 25 over 25 in your paper 3. So if you get it right here, your theory and the objective will be a small case. Are you with me? Are you with me, class? Okay. So please try as much as possible to get, it is easier to get 100% in your paper 3 than in your theory. So don't fidget when it comes to your paper 3, which is your practical. All right. These are the key points you need to know during your titration. I believe you must have done titration in your various schools, but whether you've done that or not, we know that in titration, we measure the volume of an acid that reacts with a certain volume of a base. The volume of the base is always fixed because you use pipettes to measure it. So you measure the volume of an acid that neutralized a base, okay? And you know that you'll be given at least the concentration of one of the reactants. They either give you the concentration of the acid and ask you to find the concentration of the base, or they give you the concentration of the base and ask you to find the concentration of the acid. So let's assume you have HCl plus sodium hydrogen carbonate. You know this will give you sodium chloride plus water plus CO2. Good. Since you know that the mole ratio here is 1:1, you know the mole of HCl that is required to neutralize 1 mole of a base. Since we know this relationship, that is why it is possible to find the concentration of the base when you already know the concentration of the acid. That is why it is possible to find the concentration of the acid when you know the concentration of the base, because in the equation of reaction, we can see the mole ratio. All right? So let's begin with the key points in titration. Please, is there anybody who doesn't know what titration is about? Anyone? Okay. Now, these are the things you should know in titration. In adding your methyl orange or whatever indicator you are using, either methyl orange or phenolphthalein, but you're likely going to use methyl orange because of the kind of acid and base you were given. So please do not add more than 2 drops, okay? If you add so much drop of the indicator, it may shield or prevent you from seeing the exact endpoint, okay? Please do not add more than 2 drops of methyl orange, okay? Secondly, all values on your titration table must be in 2 decimal places, including the average volume of acid used. So if you are plotting your table, don't worry, we are going to plot table today. If you are plotting your table and you measure the volume of acid as 23, please, it must be 23.00 in 2 decimal places. If you measure 25.1, you write it 25.10. Your measurements must be in 2 decimal places. Even your average volume of acid used. When we start plotting table, we'll still revisit those points. Okay? Your table values and your average volume of acid must be in 2 decimal places. Okay? Then, after your table, if you are doing calculations, your table and average volume of acid, if you are doing calculation, any other calculation, concentration, or any other calculation apart from your volume of acid used and your table, any other calculation, you leave your final answer in 3 significant figures. Please, there is a penalty if you don't do these things, okay? It's not a big deal. If you can get your answer, you can leave it in 3 significant figures, okay? The burette readings should be recorded. Please, can you see this, my write-up clearly, or should I zoom it?
I can see it clearly, ma.
Okay, all right. So your burette readings should be recorded to the accuracy of 0.1. What do we mean by this? If you are measuring your burette, let's say this is a burette. The burette is calibrated from 0 to 50, okay? 50 at the top, at the tip. From 0 to 50 cm cube. From 0 cm cube to 50 cm cube. That is the calibration of the burette. Okay. Now, if you are measuring your volume, please, you must record your readings to the accuracy of 0.10. What do we mean by that? You can get 25.4 because in the calibration, you have tiny, tiny marks. Apart from the long marks, you have tiny, tiny marks too in between. So if this is 25, assuming this is 25, then this is, and this is 30. This is 25.1, 25.2, 0.3, 0.4 till it is about 10 tiny lines. 25.990. Okay. You cannot measure 24.45. No. Are you following, class?
Yes, ma'am.
Good. You can only get something like 25.4, 28.9, 30.0, or 30.1. You can't get 11 or 15. So make sure your last digit is 0. The second decimal place is 0. Okay? There is nothing like 30.15. Okay? If you are taking burette reading. Okay? Then, okay, I think I've even explained this further here. Then, okay, I've talked about 2 decimal places. Penalties involved in acid-base titration. Please pay attention. Very important. You know that you were told that if you cancel your table or you mess your table up, some marks will be deducted from you, from your score. Some of you, because of this, have decided that all I'm going to use this WAEC for my table is pencil. I have students and this is a very big problem. Please know you that if you use pencil in any part of your answer script, I mean where you are meant to write your answer, maybe you are drawing your table or writing solution and you use pencil, they would deduct 2 marks from there. Okay? So any candidate who answers any part of the question in pencil loses 2 marks. And as usual, in chemistry, the unit is as important as the answer. So if you carry out any calculation, you must put your unit. No unit or wrong unit, -1. Then, consistently reading burette to the nearest whole number or to 1 decimal place, -2. For instance, if your burette reading, you have initial reading 0.0, final reading 25.1. This is 1 decimal place, -2 for you. Okay? If you write 25.00, correct. If you write 25, that is whole number, no 2 decimal places, -2 for you. So please, in your table, don't forget your 2 decimal place, not 1 decimal place, not whole number. Then arithmetic error is -1 for each lapse to a maximum of -2. Arithmetic error, just error during your calculation. Maybe, okay, I'm coming, Chiamaka. Arithmetic error, maybe you are meant to calculate your average volume of acid and you have 25.00, 25 point, okay, no, let me use, you're calculating concentration, okay? You're meant to multiply the concentration of the acid times 25 of the base, as example, over volume of the acid 20 times 2. and you mistakenly put the volume of the acid here instead of the volume of the base. Okay, maybe you're calculating Ca. Then you mistakenly put the volume of the acid here instead of the base. They will remove -1 for this error, okay? But if you continue your calculation and your step is correct, you will get the marks for the step, but this error will be -1, okay? We call it error carried forward. We'll mark all the steps that are correct and mark this error wrong. All right, Chamaka, your question.
Okay, ma. You said any candidate who answers any part of the question in pencil. So that means pen or true.
Yeah. I'm coming. I will tell you how, I will suggest how you should do it, because if you mess up your table, that's if you mutilate a lot in your table, it is also a problem, okay? So we'll talk about how you can do this without using pencil, where you are meant to write your answers, okay? All right. Chamaka, are you with me?
Yes, ma'am.
All right. Putting down the titer values without showing, you're welcome, showing how they are arrived at, mark accordingly and deduct 4 marks. Now, your table has about 8 marks. Imagine if they deduct 4 marks from you. What they mean by this statement is, for instance, remember in your titration, your initial volume may be 0.00 and your final volume is 23.50. Then instead of you putting this down and 23.50 down, you came down and just wrote the titer values, 23.50, the second titer value, 23.60, the third titer value, 23. Let's say 90. If you write the titer values like this without showing how you arrived at this, without showing your initial reading and how you subtracted to get the volume of acid, they will deduct 4 marks in total, 2 marks for each set, 2 marks for each set. You know your titration table may be up to 3 columns. Once they deduct 2 marks for 1 column, 2 marks for the second column, they will now leave you alone. Okay? Then the 6th one, deliberate alteration of titer values to agree with the teacher's titer value, -2 for each lapse to a maximum of 4 marks. This is where we will focus more on. Now, because, you know, it doesn't matter if your teacher is correct or not. You will be judged by your teacher's titer value. So if your teacher did the experiment in the night, when the teacher prepared the solution and got 23.5, and when it was the following day, you are not doing your practical. Remember, dilution continues until you finish with your solution. So by the following day, the solution your teacher prepared must have been diluted further, because if he dissolved sodium hydroxide in 100 ml, in 1000 ml solution and shake and use it immediately, you can never tell that everything is thoroughly mixed and well diluted. Okay? As the day passes by, dissolution continues. Okay? The following day, there may be a slight change in the concentration, because maybe that day he prepared that reagent and did the titration. Some particles did not fully dissolve, and he can't see it because it's very tiny. So that is why it's advised the teacher is advised to do the titration while the students are carrying out their own titration. But nonetheless, whether your teacher did before or not, you will be judged based on your teacher's value. Now, please listen attentively. At this point in time, you have no business not listening to your teacher. If he asks you to do anything, wash any burette, do anything, please do it. Now, sometimes teachers, because of this condition, teachers give out their endpoint. Now, when your teacher gives you his or her endpoint, he is not asking you to use that endpoint. He's just giving you that as a guide. Okay? Don't worry, we shall plot tables. Okay? Now, if you are plotting your table and you wrote 23.80 and you discover that your teacher's endpoint is 50 and you start trying to make this 8 to look like 5, you are deliberately altering your title value, and that is what they said. You will be 2 marks will be removed for each alteration until they have removed 4 marks. Once they remove 4 marks, they will leave you alone with every other alteration you are doing. But if your table is 8 marks, 4 marks is a big number. Are you following, class?
Yes, ma.
All right. Cancellation of table, that one is even the worst. Cancellation of your table of title values and making another table to be within the range of obtaining the maximum mark, you deduct 4 marks. If you cancel your table and wrote another table to put values that will match with the teacher's value, 4 marks will be deducted. Okay? Then, any candidate who uses 0.00 cm³ of the initial value but fails to record the volume of acid used loses mark. I will still explain this. This is talking about, remember you have your final burette reading and your initial burette reading, and then volume of acid used. If your burette is calibrated from 0 to 50 and you carry out your experiment, your initial burette reading, if you filled the burette to this mark, your initial reading is 0.00, okay? Then if you carry out your titration, then you discover that the volume of acid you used is from 0 to, let's say, 20. You now write 20.00, okay? Now, if you do this without writing the volume of acid used, the volume of acid used is the difference between this. From here to here is the volume of acid used. So you must say 20 minus 0, okay? If you don't say this, that's what he said. That's what they said. If you don't give us this difference, minus 2, you lose 1 mark for each alteration. For each mistake, this mistake, until they remove 2 marks if you did it more than once. Okay, now let's go to plotting of table, because that is where we are going to use this. Candidate title values agreeing with 0. plus or minus 0.15 cm³ of the teacher's title value, you'll get your full 4 marks. If your title values have a difference of 0.20 from that of your teacher, 1 mark will be removed, so you get 3 marks. If your title value, the difference between your own title values is like about 0.3 from that of your teacher, 2 marks removed. Then, okay, 2 marks awarded, please. The total mark is 4 marks. Then, if it is 0.4, in all your table, you will get 1 mark. So, how do we solve this problem? how do we solve this problem? So let me use this as an example. Assuming your teacher has a title value, your teacher, this is just an example, please. Assuming your teacher has a title value 23.20, okay? That's the endpoint given, 23.20. And you are plotting your table. So let's plot a table having this in mind. Please, my dear, you have your answer script. You have your question paper. You can decide to go to the front of your question paper and draw your table. When everything is set in your table, you can transfer what you have in front of your question paper to your answer script where you are meant to write the table. Don't go to your answer column and draw a table and cancel or mutilate. If you are able to access A4 paper, fine. If not, use the front of your answer script and do all the rough you want to do. Okay? So assuming my teacher has this as the endpoint, let us plot a table that will rhyme with this. Remember, if the difference, please, this is what I advise my students. Make sure your value is with the difference between your value and that of the teacher is within the range of 0.1, okay? Let it not be more than 0.1. You've seen what this thing says. If the difference is 0.15, you get your full mark. It's 0.4, 3 marks. 0.2, 3 marks will be awarded. So to be on the safer side, try as much as possible that your title value is within this range. If you're comparing with your teacher's value. So assuming our teacher's value is 23.20, let's plot a table. Okay. Burette reading. Burette reading in CM cube. This is a must. CM cube is a must. First reading or first in CM cube. Second in CM cube. In CM cube, please don't forget this unit. I'm just going to use like 3. Third in CM cube. Final reading first. Final reading. When you have this at the CM cube on this top, you will not be penalized if you don't have it here, okay? If you have it at the top of each column, you will not be penalized for the rule. Initial in CM cube, then volume of acid used. Volume of acid used in CM cube. Okay. We assume that our teacher's endpoint is 23.20, and I want to plot my table. You can decide to start anywhere, but I prefer to start from 0.00. Okay, let me start simple. I'll fill my burette to the brim So my initial burette reading is 0.00. And after titration, remember I have this in mind, my teacher's endpoint. After titration, I will get 23.20. Then, in my second titration, let me write, let's calculate the average volume of, the volume of acid used here will be what, class?
23.20.
23.20. Good. Now, in my second titration, I may decide to start from 23.20. Where this one ended, I will start. If not, I can start from 00. If you know calculation will be difficult for you, start from 00. Nobody is penalizing. What it means is that after each titration, you refilled your burette. Okay? That is what it means. After each titration, you refilled your burette to 0 point. That is what initial volume 0.00 means. Okay? But assuming I did not refill, I started where I ended the first one. That means my initial volume will be 23.20. You go to the front of your question paper or answer script and check what value will minus 23.20 and give me maybe something like 23.30. Are you with me, class?
Yes, ma'am.
So make S the subject of formula now. Make X the subject of formula now. What will it give us? Hello, can you hear me?
Yes, ma'am.
Okay, so tell me what I should write here as my final volume.
46.5.
What? I can't hear you.
46.5.
0.
Good, good, very good. 46.50. So my volume of acid used now will be this minus this. This will give us what? This will give us 23.30. Okay. Now, if you look at this, the difference between this and my teacher's endpoint is just 0.1, right? So I'm still on the right track. Then the third titration, I might decide to do the third titration well or do whatever I like, okay? If I decide to put this 0.00 and maybe in my final volume, I got 24.00. 24.00. Okay, 24.00. Then the volume of acid used will be 24.00. Just a minute, please. Okay. Are you with me, class?
Yes, ma'am.
Okay, good, good, good. Now, the next step, our table is okay. First of all, we considered our teacher's title value and we used it. So because of what I did, my values, my title values are not so much different from the teacher's title value, except the last one, because the last one is so far away. Are you with me? Hello? Can you hear me?
Yes, ma'am.
Yes,
Okay.
ma'am.
Good, good. My first volume of acid is 23.20. Second is 23.30. Third is 24.00. The third value is too far away from this and this. Please, while you are considering your teacher's value, you're also considering the values in your table. If you are calculating, remember you will calculate average volume of acid used. Average volume of acid used. You use only the concordant values. That is the values that are consistent. The values whose difference is not more than 0.1, 0.2. Okay. Are you following, class?
Yes, ma.
If I want to find average volume of acid used, the only values I will use will be this and this, because this is too far. This is 24. 24.00 minus 23.30. The difference is about 0.7, right? Am I correct? Please check.
Yes, ma. Yes, ma. You're correct.
Good.
0.7.
Good. Good, which is too far away. So it is greater than 0.2, so I cannot use it. It is we call it an anomalous value. You know what I mean by anomalous? Abnormal. Are you following? So it shows that there is a mistake here. That was why you got this. So in your average volume of acid used, you use only the two values, 23.20 plus 23.20 over, you know how to calculate average. This plus this divided by 2 because we used only two values. If we use three values, it will be divided by 3. Are you with me, class?
Yes,
So
ma.
give me, okay, 30, this 30. So give me the answer to this, please.
23.10.
23.10 cm3. Is it 10? No, it shouldn't.
It's 1.
This is 23.20, 23.30. It shouldn't be 0.1. It should be 2 something. Please check.
2.5, ma.
Should be 2.5, my dear. Yeah. 23.25. This is how mutilation starts. So do this in front of your paper. 2.5. Okay. So if you look at this, see your teacher's endpoint, and now see your titer values. See your own endpoint, which is the average volume. See your own average volume. It is not more than 0.15. It's actually around 0.05. Are you with me, class?
Yes, ma.
So to be on a safer side, please don't move more than 0.1. Even if you move 0.2, you'll still be okay, but please, to be on a safer side, don't move more than 0.1 difference from your teacher's endpoint. Are you with me?
Yes, ma.
Okay, very good. Good. Now I have a task for you, so tell me when you are ready. Then we do a task. You use this teacher's value. Assuming your teacher's value is 24.15. Plot a table, a titration table for me now. If I call your name, when you are done, if I call your name, you tell me what you have. So I'm waiting for you. When you are ready, let's start the task. Someone's hand is raised up. Who is that? Let me see. Are you ready? Please, if your hand is raised, please ask your question, please.
24 point what?
24.15. So use that and plot your own table. Use that and plot your own table. If I call your name, you give me your table values. We'll analyze it. So let's time this. Let me give you 2 minutes. Is that too much? 2 minutes. And I will ask you whether you have units on your table, the columns of your table, whether you have 2 decimal places, any one you miss. Remember, you are missing a lot of marks. Okay. Whenever, if you are ready, you raise your hand up. We'll start from you so that I don't need to wait for the whole 2 minutes to elapse. Okay. Edit is ready for us. Okay. So Edit, tell me. Okay, your hand was raised now. Do you have any question? Okay. Okay, your question, Edit. Okay, we've exceeded. Edit, are you just joining? Edit, are you just joining? Hey, no. I have thought it's getting to 1 hour. This is 45 minutes since we started. Anyway, we are still at the preliminary part, but very important part. So if I am not able to come back to revisit this Edit, you must watch that video, the video for this class, today before tomorrow. Okay? I gave them the task to plot a titration table for me, assuming the teacher's endpoint is 24.15. Okay? So maybe you will now take part in the calculations we have. Esther is ready for us. All right, Chamaka, move. Tell me what you have in the first iteration, initial volume, Chamaka.
0.00.
0.00. Okay. Do you have cm cube on each column?
Yes, ma.
Okay, good. Third, in cm cube. So your initial is 0.00. Okay, your final one.
24.15.
24.15. Okay, the second one.
My initial is 0.00.
0. Okay, sorry. And I like the fact that you're starting from that so that you don't need to kill yourself with calculation. Okay, your final?
24.20.
24.20. Okay, good. Your third experiment?
0.00.
0.00. Okay, your final?
25.00.
25.00. Good, good. So your volume of acid used?
24.15.
4.15. This one?
24.20.
This one?
25.00.
Good. So if you are calculating average volume of acid, which one are you using, Chiamaka? Which values are you using?
24.15 plus 24.20.
Okay. Over what?
2.
Very good. Okay. You've done well, Chiamaka. You did very well. But class, please take a look at Chiamaka's table. Did you discover any error? If you did, say yes. If you did not, edit. Okay, I'm coming to you. If you discovered any problem with this, any value here, can you indicate, class? Please take a look at her table. I'm waiting for you. Did you discover any problem? Chiamaka, also look at your table because I discovered a problem. Okay. Mother Abuchi, speak up, please.
You said
Your
that
hand is okay.
while you were teaching, you said that the decimal point must be 00. So that is what I discovered.
Okay. So which one do you think is wrong?
Volume of acid, that is the first item, 24.15. I was thinking it should be 00.
Okay, not actually, but you actually pointed out something, but it's not necessarily 00. Okay, it's not necessarily 00, but there is something you pointed out, which is correct. Any other information, any other observation in this table? Okay. Remember, I told you that in the burette, you cannot read 24.15 because the burette is calibrated this way. If this is 24 point, if this is 24, actually you will not see 00 there. If this is 24 and this is 25, you will have 10 tiny marks. 1, 2, 3, 4, 5. Each one is 0.1. Are you following? Each line in between. Are you with me, class?
Yes, ma'am.
Good. Each line in between is 0.1. So the first line after 24 is 24.1. The second line, that's those tiny, tiny marks, is 0.2, 24.2, sorry. The next is 24.3 until 24.9. Then you see 25.0. So you cannot read 24.15. Well, because the degree of the accuracy, how do I put this? The tiny, tiny marks is called precision, I think. It's called precision. Each mark represents 0.1, okay? So from 24, you get 24.1, 24.2, 0.3. You don't have 0.15, 0.25, 0.23. No. Chamaka, are you with me?
Yes, ma'am.
Good. The burette is calibrated. The accuracy is to 0.1. Each mark there represents 0.1. So you don't have 0.15. Are you following? So
Yes, ma'am.
Chamaka, correct this. What should this be?
24.20.
Good. You can say 24.20 or 24.10. Are you with me?
Yes, ma'am.
So let's go with 10 since you have 20 here. So let's go with 10. These are the things you do in front of your paper, of your question paper before you go to your answer column. Okay? So this becomes 24.10. If you do this, you will get 24.15, which is similar, it's exactly with your teacher's title. Okay, another person, please give me your value. Chamaka, is this taken?
Yes, ma. Thank you, ma.
Okay, you're welcome. Who else is ready, please? Who else is ready? Okay, Marvel. Good. Marvel is ready for us. Marvel, give me your... I'm coming. Let me clean the final. And this. Okay, Marvel, we are ready
Ma.
for you. Give us your own table. Give us your own table. Please, I am spending time here because this is where you, if you make a mistake, you will lose a lot of mark. Please.
I
Okay.
have my first, second, and third. Then I
Good.
put CM.
Good. Good. Initial.
Then I have my initial 0.00.
Okay. Final.
Right now, 24.20.
24.20. Very good. Volume of acid.
24.20.
20. Okay. Then your second reading. Initial.
Initial 24.20.
Good. 24.20. Okay. 24.20. 24.20. Okay.
Then 48.40.
Okay. 24.20. 48 point what?
40.
40. Good. So volume of acid.
24.20.
Good. 24.20. Good. Your third titration.
In my third, my initial is 0.00.
Good. Final.
24.00.
24.00. Excellent. So your volume of acid used.
is 24.00.
So your average volume, tell me what you used.
First and second.
Okay. You know, if you use the 3, it is still correct. I hope you know that.
Yes, ma'am.
Because the range is still within 0.2. Okay. So let's say use first and second, 24.20, 24.20. Please, the minimum number of values you use, the minimum, I didn't say the maximum. The minimum value, number of value you use for your average is 2. You can use 3. For instance, we can use 3 here. You can use 4 if you have 4 tables, 4 columns, okay? But the minimum is 2. So she's correct using 2, okay?
My
So this will
answer
give
is
you 24.20. Very good. Any other person with different values, please? Any other person with different values? Mava, you did great. Well done. Any other person? All right. I think this will help you to know how you can manipulate your values, assuming you have an endpoint. Please listen. If you are writing your exam, you must do your titration before you start plotting table. If your supervisor comes to your table and there is no pink solution showing that you've done your titration, no acid in the burette, nothing, he will say that you manufactured, you got your scores from phone. Please do at least one titration before you start plotting your table. Please, let's move to calculations. We have learned how to plot table. Any question, Chamaka? Your hand is raised. Any question?
Yes, ma'am. In a case where they don't have any this thing,
Any what?
any chemical for the titration. So what are
Any
we going
what?
to
Chemical.
any they didn't set
Yeah.
up anything for the titration.
Now listen. If they did not set up anything for titration, you people should beg your school authority, even if it is any acid they should bring and keep, even if it is they should bring something and keep, and you do a little titration, just show a pink solution and acid in the burette. Please, it is very wrong for you to start plotting a table without any titration, okay? The reason why some teachers release endpoint is because you are judged based on the teacher's endpoint. Secondly, if there is no table set up for your titration, there is no exam going on. If the supervisor is to do the right thing, the supervisor will not share your script. He will tell you whenever you are ready for the exam, you let them know. Please, no setup, no exam, ideally, okay? So if a supervisor distributes a paper when there is no setup, that is very, very wrong. And if WAEC finds out, whether external syndicate, that school is in trouble, okay? That school is in trouble. All right, any other question? So even if your school doesn't have, please beg them, if it is contribution, go and get just small quantity of acid, set up something, put methyl orange, put base, and it will become pink. Then you drop it as evidence, please. Because it's very, very wrong. As a student, you should be familiar with this experiment before your exam. Okay, let's go to practice question. We have 1 hour left, so let's move to calculation. Any other question? Madabuchi, you have any question?
Okay. I wanted to raise my.
Okay. Please, if your school doesn't have any setup, contribute money, because it is not about, okay?
Even though we contribute, they will still not do it because level of people doing my practice more than we that is not doing.
Yeah, it is still, Okay, it is not about those doing malpractice, okay? It is just about you. If an external syndicate, external supervisor comes to your hall, even if all the students are doing malpractice and there is a setup and you are not doing malpractice, at least you have a chance of them releasing your results and holding other people's results. Please, even if all the students are doing malpractice, let them set things up for you. Give them an evidence, okay? Let me tell you, it is a lie from the pit of hell that you cannot pass without malpractice. I did not pass my exam without malpractice, okay? Even though I did not get all A's in my WAEC, I did not get all A's in my WAEC. I got C in chemistry, B in geography, okay? I did not get all A's. But if I trusted malpractice, I would not be sitting here to teach you. I did not get A's, but I am a good teacher. So you should be able to defend what you have. Please, it is a lie. We were about 5 in our set that did not do malpractice. They just brought us at the front of the hall. We sat in the front. It was even good because there was less disturbance for us at the front. Okay? Please, you can do this. Yeah, you can do this. It is a lie from the pit of hell. I've told you, you can make 25 over 25 in your practical. Just put your mind to it. Yeah. Yeah. Okay. It's okay. It's okay. Let's move to calculation, please. Sometimes it is not about he that willeth. It is of God that showeth mercy. Okay? If you do all the malpractice and get all A's, you will still go to the university. Just be able to defend your results. You go to the university, nobody will be there to write for you. Okay? Let's move, please.
Yes, ma. Thank you, ma.
You're welcome. Calculation. You may not have the time to write all this down. You can screenshot, and I can also send the notes to the admin after this class. But I just need you, any question I display, you write out the parameters so that when we solve the problem, you will know what we are doing, okay? Someone should read this question for us. One person, please.
A is a solution of HCl. B is a solution containing 1.3 gram of sodium hydrogen trioxocarbonate 4. It's NaHCO3.
Okay.
NaHCO3 salt.
Just say sodium hydrogen carbonate. Let's move. Sodium hydrogen carbonate. Let's move.
Okay, ma'am. Put A
Say
into
it.
a burette. Sodium hydrogen trioxocarbonate 4.
Sodium hydrogen carbonate. Say it.
Sodium hydrogen carbonate.
Very good. Let's move.
Okay. Put A into a burette and titrate it with 20 cm cube or 25 cm cube portion of B using methyl orange as indicator.
Okay. Okay.
Repeat the titration to obtain concordant theta values.
Okay.
A AI tabulates your results and calculates the average volume of A used. II
Okay.
write a balanced equation for the reaction in the titration.
Okay.
B, from the results and the information provided, calculate a concentration of
Sorry.
sodium hydrogen carbonate.
Okay. Let's pick the questions one by one. Just a moment. I need to transfer this because my battery is running low. Let me transfer this to my phone. I don't have lights. So Okay. Come on, please. Just a moment. Okay. Yes. Good. Okay, let's go. She's not yet here. Okay, let's continue. I just hope this enters. Okay. The first question says, write a balanced equation for the reaction. What is the acid used, class? What is the acid used? HCl. The acid used. I said, what is the acid used? The first question says, tabulate your reading and everything. After everything, the second one says, write a balanced equation for the reaction. So what is the acid used?
HCl.
Okay, HCl. Sorry, I thought you said HCl. HCl plus the base is sodium hydrogen carbonate. Okay. When an acid reacts with a hydrogen carbonate, it releases carbon dioxide. So it gives you the salt, sodium chloride plus water, then plus carbon dioxide. You balance the equation. So this equation is balanced if you check carefully. You are likely to be given sodium hydrogen carbonate and HCl. Okay, so that is why we are using this as the acids, the reactants. Okay, let's go to B. We have BI, B capital I. Concentration of sodium hydrogen carbonate in moles per dm cube. Hello, class. We don't know the concentration of HCl in moles per dm cube. And to find the concentration of the base, we cannot use CAVA equals to NA and over. okay? Because we don't know the two concentrations. But for the base, we have the mass dissolved in 250 cm3. So we can find the mass concentration of the base. The question says concentration of B in moles per dm cube. That is the question. So first, find concentration of B in grams per dm cube. Because we are given something that we could use to do that, right? Are you with me, class?
Yes, ma'am.
Good, good. So how do we find the concentration of the base in grams per dm cube? We have already treated concentration in the past during JAM class. We treated concentration. So you can use different ways, proportion or formula. If I'm using formula, concentration in grams per dm cube is equals to mass over volume. Your volume must be in dm cube. Are you with me, class?
Yes, ma'am.
Good. The mass of the base from the question is what?
1.30.
1.30.
1.30. Why the volume is what? Give me the volume in dm cube already.
1,000.
Give me the volume in dm cube. Is the volume 1,000? They said 1.3 dissolved in 250 cm cube. So the volume is not 1,000. So give me the volume here in dm cube. I'm waiting for you. Convert 250 cm cube to dm cube. This is simple.
11.16.
What?
11.16.
No.
Serious. 250 dm.
0.85.
250 cm. Just count 00 backward and you get it.
0.25.
0.25. Simple. 1, 2, 3. It means divide by 1,000 cm cube. You get 0.25. Okay? So our volume in dm cube is 0.25 dm cube. So give me the answer to this question. 1.3 over 0.25. Give me the answer.
5.2.
5.2.
5.2. So the mass concentration is 5.2. What is the unit?
GDM cube.
Good. Grams per dm cube. Grams per, please, not just gram dm cube. Gram per dm cube. Grams per dm cube. So we now know the mass concentration of the base. We can now find the mole concentration of the base, which is what we have in the question. So how do we do that? How do we do that? How do we find mole concentration? I need one person to say something from mass concentration.
We can use C1V1.
C1V1 is mole concentration. Remember, the question says find the mole concentration of the base. Okay? Now, if you use CAVA over CBVB equals to NA over NB. We don't know CA. Look at the question. There is no concentration of the acid. Okay? And we don't know CB. So we cannot have two unknowns and be able to use this formula. No. Are you with me? Are you with me?
Yes, ma'am.
That is why the first thing I'm trying to find is this, which is the first, where is the question? BI, this one. It says the concentration of the base in moles per dm cube. Now, we cannot use this formula, you know, but we have mass dissolved in a known volume. With this, we can find the mass concentration of the base, which we have done. If we know the mass concentration of the base, we can find the mole concentration of the base, which is Cb. So it's not necessarily this that we need. We can't use this because we have two unknowns if we put this. So remember, mole concentration, that's C. C in moles per dm cube is equals to mass concentration. Okay, class, do you remember this formula? Number of mole equals to mass over molar mass. Do you remember this formula? Do you? Okay, good. This formula was used to deduce this formula I'm about to write now. Concentration in mole per dm cube is equals to mass concentration, which is concentration in grams per dm cube, over molar mass. Do you remember this formula?
Yes, ma'am.
Good, good. So with this, we can find concentration of the base in mole per dm cube. Okay? Let's do that. So concentration of B in moles per dm cube will be what? What is mass concentration? Are you keeping quiet?
Is it 1.30?
The mass concentration. You know the meaning of mass concentration. Mass concentration means the mass dissolved in 1 dm cube. That's the meaning of mass concentration. What we have in the question is the mass dissolved in 250 cm cube. So the mass dissolved in 1 dm cube is the mass concentration. That is why we have to convert it here. We did 1.30 over 0.2. That gives you the mass dissolved in 1 dm cube. That's why we said grams per dm cube. Are you with me?
Yes, ma'am.
Good. Or you can use proportion. You can say if 1.30 gram is dissolved in 250 cm cube, that is, I'll cover it with them. That's 0.25 dm cube. Then, how many grams is dissolved in 1 dm cube? 1 dm cube. The gram dissolved in 1 dm cube is mass concentration. So if you do this, you will still have 1.3 divided by 0.25, which will give you this. Okay? So the first step, remember the question is calculate the mole concentration of the base. But we can't do that without finding the mass concentration. That is why I have to find the mass concentration first. Okay? Now we have the mass concentration. We use this formula to find the mole concentration. So what is the mass concentration we have on the screen?
5.2.
5.2 over molar mass. Please, you have to tell them how you got the molar mass. You have to tell them, okay? This is 23 plus 1 plus 12 plus 16 times 3. Okay? This will give you 84 grams per mole. So since this is your titration calculation, we tell them 84 grams per mole. Then you bring it down here. So please give me your mass concentration. Transfer that. Tell me what you've got.
0.0619.
Very good. Write it down. 0.0619. A moment, please. Okay. Very good. We are good. Okay, 0.0619 moles per dm cube. So our CB, which is concentration of B in moles per dm cube, is 0.0619, right?
Yes, ma'am.
Moles per dm cube. Remember what we said. Your calculations, your final answers must be in 3 significant figures. So this is approximately 0.0619 moles per dm cube. Any question? Any question? Okay, please put it down before we move. So that when I send you the notes, I would like to send you the note with this, but I don't know in case I clean it. Are you ready?
Yes, ma'am.
Okay. Okay. So let's go to II. The second question says concentration of the HCl in moles per dm cube. Now you can use CaCb since we have Cb. Are you with me, class?
Yes, ma'am.
Good. The acid is A. BII. BII. I. Concentration of the acid in moles per dm cube. Please solve that problem and give me your answer. Ca Va over Cb Vb equals to Na over Nb. Na is the mole ratio from the equation of reaction. Go to the equation of reaction. If you go to the equation of reaction, the ratio of the acid to the base is 1:1. Am I correct?
Yes, ma'am.
Okay. So here we are looking for Ca, which is the concentration of the acid. Make Ca the subject of formula. This will give us Ca equals to CbVb Na over VaNb. So substitute correctly and tell me your answer, please. I'm waiting for you.
But please, can we see the question?
Okay.
Our base is what?
Yeah, what?
Volume of base.
Okay. Thank you for that. I assume that our volume of base, everybody should use the same volume. Our volume of base is 23.95. VB equals to 23. Sorry, VB is pipette, so 25.00. Okay. VA equals to 29 point, I keep doing 23.90. 23.90. Thank you for that. 95, please. Remember, VB is the volume of the base you pipetted, so it is constant. Then VA is your average volume of acid used. So we assume that our average volume of acid used is 23.95. So use it for your calculation.
I'm getting 0.0647.
What?
0.0647.
0.0647. Okay, who got a different answer? Because that is correct. 0.0619 times 25 times 1 over 23.95 times 1. This will give you 0.0647 moles per dm cube. Any confusion?
No, ma'am.
Okay, please, if this thing logs us out by chance, still wait for me. I'll join with my second laptop. We don't have lights here. Or even with my phone, but I don't have WhatsApp in my phone too. No. Okay. Is that taken, class? I think this is the simplest calculation you can do in titration. Let's move to something else.
But ma, I can't. I'm not understanding this thing, and that's the issue I've been having.
Who is speaking, please?
Is Esther, ma?
Okay, what is the problem? Where exactly is your problem?
Starting from the first one, the gram per dm cube, the mole per. I don't know when to use CA, VA.
Okay. Let me ask you a question. But you know the formula CAVA, right?
Yes,
right? Okay. CA means what, Esther?
ma.
CA means what?
Volume of an acid.
No. CA, I said CA, not VA. I said CA.
The concentration of an acid.
Not just the concentration. The concentration of the acid in moles per dm cube. Concentration can be in grams per dm cube. Concentration can be in moles per dm cube. So Ca means the concentration of the acid in moles per dm cube. Are you with me?
Yes, ma'am.
Cb means the concentration of the base in moles per dm cube. Please, if you don't know this, put it down. Ca means concentration of the acid in moles per dm cube. Cb means concentration of the base in moles per dm cube. Now, if you have Ca, which is the concentration of the acid, you can find Cb using this formula. Esther, do you agree with me? Esther, are you with me?
Yes, ma'am. Using which formula?
Using CAVA.
Okay.
If you know the concentration of the acid, from our titration, we know the volume of the acid. The volume of the base we know because it is the one we pipetted. It's always 25, okay? Then Na means mole ratio of the acid from the equation. You know what mole ratio means now? Do you?
Yes, ma'am.
Good. What mole ratio of the base is Nb. Here the acid is, the ratio is 1:1. Okay? So now if we are given Ca, which is concentration of the acid in moles per dm cube. And we are asked to find the concentration of the base in moles per dm cube. You know we have all we need, so we can use this formula to find Cb, right?
Yes, ma'am.
Good. But here, read the question carefully. The question says, A is a solution of HCl. There is no concentration given. Are you with me?
Yes, ma'am.
Good. Then B is a solution containing 1.30 grams of sodium hydrogen carbonate in 250 cm cube. Is this thing concentration in moles per dm cube? Esther?
No. No.
Good. This is grams and this is 250 cm cube. So we were told that 1.3 grams was dissolved in 250 cm cube. That's the base. Okay. Now, the first question here says, calculate the concentration of the base in moles per dm cube. That is Cb. That's Cb. Find Cb. That is the question. Now, we don't know Ca. Can you see Ca in the question, Esther? Is there any Ca in the question? Look carefully.
No, ma'am.
No. So we don't know Ca and we don't know Cb. So we cannot use this formula to find Cb. Because if you use this formula, you have unknown Ca. How can you find unknown Cb? You have two unknowns. Are you with me?
Yes, ma'am.
Good. You can only use this if you have maybe Ca and you are looking for Cb, or you have Cb and you are looking for Ca. Is that taken?
Yes, ma'am.
Here we don't have Ca, we don't have Cb, so we can't use this. But there is another formula we can use to find Cb. Remember, we have 1.3 grams of B dissolved.
I can't hear you again.
Really? Hello, class. Can you hear me?
I can hear you now.
Okay. We have 1.3 grams of the base, which is B, dissolved in 250 cm cube. Okay. We already know that there is a formula.
Your voice is cracking, ma'am.
Oh, hey, are you serious? Can you hear me now?
Yes, ma'am.
Okay. We know that concentration in moles per dm cube is equals to concentration in grams per dm cube over molar mass. Do you know that?
Yes, ma'am. We can't see your screen, ma'am.
Yeah. So what have I been showing all this while? So I've
No,
been talking.
It's just now that it's got.
Okay, okay. Can you see it now?
Not yet, ma'am.
Not yet. I think this battery is reacting to my. Okay, let me stop this and share again. Let me share again. Entire screen. Okay. Can you see it now?
Yes, ma'am.
Okay, good. Now, we know that concentration in moles per dm cube is equals to concentration in grams per dm cube over molar mass. Do we know that?
Yes, ma'am.
Good. Since we cannot use CaCb to find the concentration of the base, we can use this to find the concentration of the base in moles per dm cube. The concentration of the base in moles per dm cube, because we can find this for the base. Okay. Concentration in grams per dm cube is also equals to mass over volume. in dm cube. Esther, are you with me?
Yes, ma'am.
So this is a two-step calculation. From our question, they told us that 1.3 grams of the base was dissolved in 250 cm cube. That's 0.25 dm cube, right?
Yes, ma'am.
Good. If you divide that mass by the volume, you get concentration in grams per dm cube. Concentration of the base, please. Are you with me?
Yes, ma'am.
So if we do this, we get 5.2 grams per dm cube. Are you following?
Yes, ma'am.
Now we have concentration in grams per dm cube. Let's change to the next, my second laptop. Oh my God, take a long time. Just a moment. And we have about 20 something minutes. Let me see if I can meet up. Just a minute. Let's start. From what I gave you now, you can find the concentration of the base in moles per dm cube. Okay?
Yes, ma'am.
So you can find the concentration of the base in moles per dm cube. Will be the mass concentration, which is 5.2 over the molar mass, which is 5.2 over 84. That is what you gave me as 0.0647.
No, 19.
Okay, 0.0619, right?
Yes, ma'am.
Is that what you got? I don't think so. Is that what you got?
That's what we got before.
Okay, 0.0619 mole per dm cube. Now we have CB. Are you getting me? Now
Yes,
we
ma'am.
have our CB. We can now go ahead and find CA, which is the second question. Are you with me?
Yes, ma'am.
Good. We have our CB, so we can comfortably find CA. Okay, is that taken, Esther?
Yes, ma'am.
All right. Class, our CA is 0.0647 moles per dm cube. The next question says, find the concentration of the acid in grams per dm cube. Try it out. Find the concentration of the acid in grams per dm cube. I hope you are still with me. I hope they are still with me.
Yes, ma'am.
Okay. So find the concentration of the acid in grams per dm cube. And tell me what you've got. Let me display the more concentration of the acid. Good. And the acid is HCl, so let's see. Please don't come late to class tomorrow. Don't. You cannot afford to come late. I'm waiting for your response, please, while I plug in with my laptop.
2.361.
2.361. Okay. Any different opinion? So I believe what you used is Concentration in moles per dm cube is equal to concentration in grams per dm cube over molar mass, right?
Yes, ma.
So your concentration in grams per dm cube for the acid becomes the molar concentration times molar mass, which is 0.0619 times molar mass of the acid is 36.5. Please always solve the molar mass. Show how you got the molar mass before this. So if you did that correctly, you will get 2 point what, Esther? Who answered that question? 2 point what?
2.36.
36 grams per dm cube is a must. 3 significant figures is a must. Are you
36.
Ma, it's not 2.3.
is what?
It's 2.259.
And you gave me 2.3 and I wrote it. Please, any different opinion? 2.259 grams per dm cube. So approximately 2.26 grams per dm cube. 3 significant figures.
Ma.
Hello, good evening, everyone. Can you hear me?
Yes.
Yes, sir. Good evening, sir.
Okay, please, your teacher just reached out to me. Her devices are down. She won't be able to join again. So please, the remaining questions will be in the next class. So you guys can just leave the call. So the next class will be tomorrow. So you can continue your questions. Thank you very much.